Hello. It's a typically hot afternoon here in Malaysia. You reach for the switch to turn on your ceiling fan for some much needed relief. But instead of a cool, refreshing breeze, you're greeted by a shower of accumulated dust and allergens raining down on your living space. We're all too familiar with the traditional solution to this problem: dragging out a heavy ladder, balancing precariously on a chair, and risking a dangerous fall, all while the dislodged dust scatters everywhere. What if there was a better, smarter way? What if you could achieve a spotless fan while standing firmly and safely on the floor? Welcome to the future of home maintenance. Today, our team is incredibly proud to introduce our innovative mechanical ceiling fan blade cleaner, a safe, affordable, and elegantly engineered solution designed specifically for your comfort. Welcome to the future of home maintenance. Today, our team is incredibly proud to introduce our innovative mechanical ceiling fan blader, a safe, affordable, and elegantly engineered solution designed specifically for your comfort. To show you exactly how we brought this vision to life, we are thrilled to take you behind the scenes of our journey. We will walk you through our final design, show you how we transitioned from our digital CAD assembly to a fully fabricated prototype, and finally, present a live demonstration of this game-changing cleaner in action. Let's
Our project is the ergonomic fan blade cleaner, which is designed to make cleaning ceiling fan blades easier, safer, and more comfortable, especially for high-edge cleaning. One of the main problems with conventional fan blade cleaner is that they're usually top-heavy. This causes user shoulder fatigue and makes it too difficult to control when used for a long period. To solve this problem, our design uses a counterbalance structure. The water tank, which is the heaviest component of our product, is placed in the bottom part of the telescopic pole. This brings the center of gravity closer to the user's hand, making the cleaner more stable, better balanced, and easier to handle. Above the handle is a lightweight telescopic pole with a twist-lock mechanism. This allows the user to quickly adjust the length of the telescopic pole to suit different ceiling heights. Of the pole, we mounted a micro pump motor. The cleaning solution is drawn from the water tank through an external inlet tube into the pump. The pump then pushes the liquid to an internal tube inside the upper pole, protecting it from damage and snaging the reuse. At the top of the cleaner is a dual-side cleaning head. It consists of two sponges inside a rechargeable mop pads, which allow users to clean different shape and size fan blade. This allows both surfaces of the fan blade to clean simultaneously with just one horizontal movement, reducing the cleaning time and improving efficiency. The cleaning head is supported by a strong flange and includes T-shaped spraying nozzle. The nozzle sprays the cleaning solution directly onto the micro-mounted microfiber cleaning pad just before they contact the fan blade. This keeps the pad moist and improves the cleaning performance and help the trap dust instead of letting it fall onto the floor. Overall, by combining a bottom-mounted water tank for a better balance, a mid-mounted pump for efficient fluid delivery, and a dual-side spray cleaning head, our ergonomic fan blade provides efficiency, ergonomic fan blade user-friendly solution to user to clean ceiling fan blade.
As we can see, this is our SolidWorks design. To see how these subsystems integrate seamlessly, let's look at our CAD assembly and exploded view, which show how exactly we combine all these separated components into one working system. As we pull the components apart in this exploded view, you can see how everything connecting using simple user-friendly interfaces. At the base, the fluid reservoir attached to the telescopic ball via threaded bottle cap style interface for quick refills. Moving up, we have the power supply containers that combine all the electrical parts like motors and switches. And moving up, both the dust container and the sponge pads utilize the rod holders. These quick release clips can be easily opened to release their grip on the main tube, allowing to the user to seamlessly adjust the components' positions or detach them entirely for cleaning and replacement.
Moving into our physical fabrication stage, we begin by cutting the PVC into the desired size and construct the main framework. To accommodate our fluid delivery system,
we geo-matching alignment holes through both the mainframe and also the telescopic pole, allowing the water pipe to route smoothly up to the interior of the tool from the water reservoir at the bottom of the telescopic pole.
At the cleaning head, we completed the assembly by attaching the sponge pad and also the dust container securely to the head structure using root click. Next, we fix the waterproof peristaltic pump into its designated position on the telescopic pole and connect the internal water pipe from the water tank at the bottom all the way to the cleaning head.
At the beginning, our initial design required the user to turn off the power at the wall socket to stop the water flow.
But now, for our user convenience, we add a control switch right on the handle. This modification allows our user to easily and instantly control the water flow. With this adjustment in place, our physical prototype was fully completed.
I'm Chen Xiaoling.
And I'm Vicky.
Two of us will be responsible to explain the demonstration part of this presentation. Thank you.
Firstly, disassemble the water tank from the telescopic pole and fill it with cleaning agent. The water level should not exceed the maximum fill line as shown in the demonstration video. Next, reinstall the water tank onto the telescopic pole. While doing so, ensure that the water tube is carefully placed back inside the water tank without bending or pinching it. Then, adjust the length of the telescopic pole according to the height of the ceiling fan. Simply twist the locking mechanism to extend or retract the pole, and tighten the lock securely once the desired height is reached. Once the correct height is achieved, position the cleaner on the fan blade and begin the cleaning process. After cleaning is complete, lower the telescopic pole and restrict it back to its original length for easy storage. Finally, detach the replaceable mop pad. User can wash the replaceable mop pad with clean water. After drying, the mop pad can be reused for further cleaning, making the system both economical and environmentally friendly.
Hi, I'm Chen Wanxing, and I would like to talk about the challenges that we made in this project. We have successfully built a firmware cleaner that fulfills all our project objectives, but we encounter a few challenges during the fabrication process and after user testing. During the build process, we faced too many of challenges that took a significant amount of time to resolve. The first was moving water through the system. We needed to deliver the water from the bottom of the tool to the top part of the tool. This is already difficult, but because of our telescopic pod got 2.5 meters long, so gravity completely stopped the water from traveling up the long pole to the cleaning head. To overcome this, we added a small water pump to act as a driving force to push the water upwards. But our second challenge happened because of that water pump. The high pressure from the water pump caused the rigid pipes to pop open at the joints. We came up with an idea to fix it by switching to softer and better gripping pipes. We also wrapped the connection tightly with thread seal tape to prevent any leaks. After testing the prototypes, we realized that there are still a few areas we can improve to make the design even better. First, when the user turns on the switch, the pump runs non-stop. Since users cannot control the water flow, the cleaning cloth either stays too dry to clean effectively or gets so wet that dirty water drips onto the wall floor. For future improvement, we could add a simple moisture sensor to automatically regulate the water. Additionally, we noticed that having a glass box on only one side allows dust to fall out from the opposite open end. Therefore, we can add another lightweight glass box to trap all the dirt.
As you've seen today, what began as a digital model has successfully been transformed into a fully functional reality. By keeping the heavy components at the base and running our fluid lines through the inside of the pole, we engineered a perfectly balanced tool that makes high-reach cleaning feel completely effortless. Every manufacturing challenge we faced simply allowed us to refine the prototype into a practical solution that ensures your safety and health while keeping your home spotless. Thank you for your time, and we hope you're as excited about the project as we are.